Induction motors can be divided into two main groups: cage rotor motors and wound rotor motors, sometimes known as slip ring motors. Cage rotor motors are generally more efficient and have a better power factor than wound rotor motors. They're significantly cheaper, are more robust, and require less maintenance. Instead of the solid bar conductors of the cage rotors that we've seen, the rotor of a slip ring motor has a completely different construction, with coils of copper wire wound as separate three-phase windings fitted into slots. These windings are led out to three brass slip rings mounted on the shaft. In the cage rotor, the conductor bars carry a heavy current at extra low voltage, while the slip ring rotor has many more small section conductors, each carrying a much smaller current per wire. The currents induced into the rotor are collected by sets of brushes mounted within the stator housing, and through the terminal box are connected by external wiring to a starter, which includes a bank of three-phase resistors. The purpose of the resistors is to control the rotor current during starting. In this animation, we can see that as the motor is started, the total resistance of the rotor and start resistors is relatively high, and so the current induced in the rotor is low. As the motor accelerates, resistance is taken out of circuit, until at the run position there is no external resistance in circuit and the rotor windings are short-circuited. The wound rotor motor is quite expensive due to its more complex construction, and is used for applications such as pumps, crushing mills and cranes.